The question says that the number density of free electrons in a copper conductor estimated in example 3.1 is 8.5 into 10 to the power 28 per meter cube. How long does an electron takes to drift from one end of the wire 3 meter long to its other end? The area of cross section of the wire is 2 into 10 to the power minus 6 meter square, and it is carrying a current of 3 ampere. Now this question is a continuation of example 3.1, which employed calculation of average drift velocity. Now in this question we have to find out how long will an electron take to drift from one end of the wire to another end, given that there is a current of 3 ampere flowing through the wire, and we have been given the dimension of wire, that is the cross section of wire we have been given. It is of 2 into 10 to the power minus 6 meter square, and the length of the wire is also given, that is 3 meter, and the number density of electron is also given, that is 8.5 into 10 to the power 28 per meter cube. In order to find out how long does an electron take to drift from one end to another, or the time duration that the electron will take to travel 3 meter given a current, we will have to calculate the drift velocity, and time duration can be calculated by dividing the length of the wire divided by the drift velocity. So at first the expression for Vd or the drift velocity can be related to current using this expression, that is Vd equals to I divided by NEA, where N is the number density of the free electrons, I is the current through the conductor, and E is the elementary charge, and A is the cross section area. Now calculating drift time, we can divide it by length, that is L by Vd, and that will give us L times NEA divided by I, that is the current. So substituting the values, we will get a value of 2.72 into 10 to the power 4 seconds, or when divided by 3600 we can get it into hour, and that will be equal to 7.55 hours or 7.5 hours. Thank you.